Okay, we're going to look at vector equations of motion in AS2. So in last year's mechanics or applied module, we identified vector quantities such as displacement, velocity, acceleration, and force. And these have magnitudes and direction. So velocity is like speed, but it has speed, and also it has size, but it also has direction. Displacement is like distance, but it also has direction as well. So if it's a constant velocity, then remember this would have been your S is equal to Vt, where distance is equal to velocity times time. That now becomes displacement is equal, distance is equal to speed times time. That now becomes displacement is equal to velocity times time. So time is the only bit of this thing which is not a vector. Okay, so in situations involving constant acceleration, we can apply the constant acceleration formula. So you've velocity, final velocity is equal to initial velocity plus your acceleration times time. Your displacement is equal to your initial velocity plus a half times your acceleration times time squared. Also, your displacement is equal to a half times your initial velocity plus your final velocity times your t. Okay, notice I've left out the v squared one. Just gets a wee bit weird if you use the v squared one. It just sort of messes up a wee bit more awkward to use. But another one which you could add in, which is not given to you. These are not given to you in your formula booklet in this form. They're given to you in your formula booklet without the wee vector lines underneath them. So another one to add in would be that displacement is equal to final velocity times time minus your half times your acceleration times time squared. So it's very similar to this one, except it's v and the u has changed to v and the plus here has changed to a minus, and that is it. Okay, when we're dealing with forces, we can also calculate acceleration of a body of mass m by using the force vector is equal to mass times your acceleration vector. So remember, mass is just a scalar, just like time was, it's just a scalar. So it doesn't have direction, it just has size. So force vector is equal to mass times your acceleration vector. Right, in our first example it says a car is travelling at a constant velocity of 2i plus 3j meters per second, and it says find the displacement and hence the distance the car would travel in 8 seconds. So find the displacement and then the distance it says. So we're just going to write down your formula. So the formula is this, that your displacement is equal to your velocity times time. So our displacement in this case is this thing times our time, which was 8, or I'm just going to write it as 8 upon 2i plus 3j. Remember, you need your brackets. So that means your displacement works out to be 16i plus 16, that's a 16, believe it or not, 16i plus 24j. Okay, that is your displacement. Next bit it says, hence find the distance. So the distance is just the size of the thing. So the size of it is just really distance is equal to your modulus of your displacement. So we may have forgotten that from last year. So it's a modulus. Modulus is just the length of it, right? And just to show you this one time, if you draw this thing as a vector, what it's going to be, if you draw this as a vector, what you're going to have, it's 16i, means 16 to the right, and then 24j means 24 up. So 16 and 24, obviously it's not drawn very well here. The size of it, how you get the size of it, is just the diagonal. So that's all really we want. So it's a single vector, or the length of this diagonal basically takes you from here to here. So it is just Pythagoras. So that's why your modulus is, and we'll just put this in a bracket. Why I'm putting it in a bracket is because if it had been a minus, then you're not going to mess it up if you have the minus. And so if it had been minus 16i, you would put minus 16 inside this bracket. So you do that on your calculator and you press equals, and what I got when I did it on my calculator was 8 root 13, and that's going to be meters. That's an exact perfect answer, but you may want it to decimal places. So that's going to be, let's just check, 8 times root 13, press equals, SD, and what I've got is 28.8 meters, and that's the 3 sig figs. Okay, in this example it says, during a 20-second period, the velocity of a boat changes from 8i plus 12j to 6i minus 5j, where I and j are perpendicular unit vectors. Assuming the acceleration of this boat, the boat is constant, find the acceleration of the boat. Okay, first of all, I'm just going to write down, I'm going to write down what I've been given. I've been given my u is equal to 8I plus 12j, because that's what the velocity started as, and then it finishes as 6I minus 5j. So you have 8I plus 12j is your u, and your v vector is 6I minus 5j. And also, and it does this in 20 seconds, so my t is equal to 20. And what I want to find is my a. So v is equal to u plus a t. So what I have done here is I've just rearranged this to have said that a then is equal to v minus u all over t. So nice horizontal line. And then we go from here. So if you do your v minus u and just write it out and show all your steps, 6I minus 5j minus 8I plus 12j, and then that's all being divided by my t. And what on earth is my t? Where's my t? My t is 20, there we are. And then we can go from this. So that works out to be minus 2I, it's going to be minus 17j, all divided by 20. And I have just worked that out as decimals. So I've said that is just going to be minus 0.1I. I really should have that in a bracket. And then minus 0.85j. And that the units of that are going to be ms to the minus 2. This next example says a box of mass 4 kilograms is in equilibrium under the action of three forces P, Q, R, where P is equal to, we've written these as column vectors, 3, 5, and Q is equal to minus 2 plus 4j. So a bit of a mess here. We've written one as a column vector and one as normal ij form. Okay, this term equilibrium means, now if I'm sitting on my chair, I'm sitting in a state of equilibrium because there's my weight which is acting down towards the center of the earth. That's my weight, which is my mass times acceleration due to gravity. And also then there's a normal reaction from the chair going vertically upwards. So that means there's two forces acting on me and I'm not moving. I am in a state of equilibrium. So overall there is zero force. Basically the resultant force is zero. So that's what's happening here. So basically the sum for this one, for A, P plus Q plus R equals 0, and we'll just say that is because it is in equilibrium. Okay, so what we wanted to find, what did we want to find? We wanted to find R. That means R is equal to, and that's going to be minus P minus Q, and I'm just going to write these as both as column vectors, because you'll see how much easier it makes life. So my P then, that was going to be, the P which was minus of 3, 5, and the Q then, and Q was minus 2, 4. So if you were to work those both out, what you would get, it's going to be minus 3 minus minus 2, so that's minus 3 plus 2, which is just going to be minus 1, and then that's going to be minus 5 minus another 4 is going to be minus 9, and that was newtons. So they didn't specify that they wanted this in a column vector or ij form, so column vector makes life so much easier for you to write. Okay, part B says, if the direction of R is now reversed, find the acceleration given to the box. So that means we'll just say now R is equal to, so if you reverse this thing here, if this gets reversed, instead of being minus 1, it's going to be plus 1, instead of being minus 9, it's going to be plus 9. So that's what your new R is going to be equal to. That's what your new R is equal to. So my overall F, this is my resultant force, will be different. It's going to be P plus Q plus R, which is going to be the 3, 5, that was the P, the Q was minus 2, 4, and the R was 1, 9. And if you work that out, what you're going to get for your force, it's going to be 3 minus 2, then plus 1 is just going to be 2, and then that 5 plus 4 plus 9 is going to be 18. So that's your overall resultant force is 218. Now what we're going to use is we're going to use F equals ma. So vector F is equal to mass times vector A. And it must tell us in the question the mass of the box. It does. There we are. Mass is 4 kilograms. So that means fill in what you know. Your force you've just worked out to be 218. Your mass is 4. And your acceleration is what you're trying to find here. So that means your acceleration is going to be equal to a quarter upon 218, which means your acceleration is going to be a quarter of 2 is going to be 0.5 I. I'm just going to write it horizontally here. And then a quarter of 18 is going to be 4.5 J. Strictly, I need to have that in a bracket too, and that's ms to the minus 2. This example says a particle P moving with constant velocity 12I plus 5J meters per second passes through a point A whose position is 4I plus 5J at time t equals 0, so that's where it starts. Find the distance of the particle from O after 3 seconds. Okay, right, to do this question, folks, what we've got to do first of all is we've got to ignore this bit at the start. Okay, we want to find the distance this thing moves if it moves with this velocity and it moves for 3 seconds. So we want to find what distance or displacement this thing moves through in 3 seconds, and then we'll go back and we'll add on this thing at the very end. So our method here is find the displacement if you go for at a velocity of 12I plus 5J at 3 seconds for 3 seconds, and then at the very end we want to add on this thing here. Okay, right. First of all, we'll just say S is equal to VT. So that means that's 3 times my 12I plus 5J. And if you work that out, you're going to get 36I plus 15J. And that's meters in a bracket. I should have that in a bracket. And say that's in the 3 seconds. Okay, so we'll say our final displacement is equal to what we've just worked out, 36I plus 15J, plus your initial displacement, which was 4I plus 5J. And if you work that out, you're going to get 40I plus 20J meters. Okay, right. If I'm completely honest, I would have just stopped here. I would have thought that was it. Read the question again. The last part of the question says find the distance. Okay, not the displacement, but it says to find the distance. So that means your distance. And remember what we said earlier on. Distance is just the size of the displacement vector. So it's a modulus. So to put that in again, it is distance is equal to your modulus of displacement. So that's your wee modulus sign, which means the square root of brackets 40 squared plus 20 squared. And I'm just going to do that on my calculator again and check. So square root of 40 squared plus 20 squared, press equals. What I get in my calculator is a perfect answer of 20 root 5 meters. And press SD to get that into decimals. So 44.7 meters. And that is to 3 sig figs. Okay, this very last bit of the notes here says if a vector is parallel to I, then its J component is 0, and vice versa. So if a vector is parallel to J, then its I component is 0. Next thing says if one position vector is due east or west of another, then their I components or J components will be equal. So there's your north, east, south, west, and how you can remember that is never eat shredded wheat. And so if they're east and west of each other, then they're the same height basically, so their J bits will be the same. Likewise, if something is north or south of something, then there you go, and their I bits would be the same, their I components would be the same. Okay, and the last wee bit just says if two vectors are parallel, then one is a scalar multiple of the other. So if you had A, which was equal to 2I plus 6J, and B, which was equal to 4I plus 12j, then your B could be written as 2 times 2I plus 6j, which means A is equal to, sorry, I should, yep, A is equal to, B is equal to 2A, B is equal to 2A, so that means they are parallel to each other, and that's it.